Hold your hand out in front of you. Go on, palm up, held there in the air. You can feel it, can't you? That small, patient pull downward, the plain weight of your own hand wanting to sink back to your side. Now, here's a question that sounds far too simple to be worth an evening of anyone's time. Why? Where does that heaviness actually come from? The sheer fact that your hand weighs something at all? And for most of the long history of physics, the honest, rather embarrassing answer was, nobody had the faintest idea.
And when the answer finally arrived, it was stranger than anyone had ordered. Picture this. Every scrap of empty space around you, the room you're sitting in, the miles of nothing overhead, all of it quietly soaked in an unseen field. Always there, never switched off. Some particles shove their way through that field as though it were thick as honey and go about heavy for their trouble. Others slip through it as if it simply weren't there at all, and stay weightless and fly forever at the speed of light.
So that's the whole of it then. That's where my hand's weight comes from. Invisible treacle everywhere I go, and I'm one of the poor souls wading through it.
That's the story the world was told, more or less. Here's the trouble with it. That famous field, the one they threw the parties over, the one that made every front page on Earth the day they finally cornered it, gives you almost none of your weight. Almost none. Step on your bathroom scale tomorrow morning, and very nearly every notch it reads has nothing to do with that field whatsoever.
Hang on. You've just spent 3 good sentences selling me a field that fills the whole of space and decides what's heavy and what's not, and now you're telling me it isn't the reason I'm heavy.
I'm telling you precisely that, and I'm not going to tidy it away for you yet, because the tidying away is where everyone goes wrong.
Wonderful. So, somewhere out there is a field the entire species celebrated finding. It's the reason anything has any weight at all, and it's responsible for near enough none of mine. That's a proper insult when you sit with it. I turn up wanting my own weight explained, and the headline answer turns out to be about somebody else.
About the smallest somebodies there are, in fact. And that gap between what the field actually does and what everyone thinks it does is the whole of tonight. So hold your 2 questions up where we can both see them.
And kept honest, mind. No quietly sliding one answer into the slot where the other belongs. If the field's the famous thing, it had better do famous work. And if it doesn't do mine, then I want to know whose work it does do.
Kept scrupulously honest, both of them, side by side the whole way. Because the plain truth here is stranger and finer than the tidy version everyone repeats.
2 questions then, and I want both answered before you let me leave. What in the world is this field? And if it isn't the thing making me heavy, what is?
Both fair. And you'll have both plainly. But to earn either one honestly, we have to go back and pick up the thread you were left holding last week. The splinter I slid under your nail on the way out the door.
The sting at the end. We'd spent a whole evening on that gorgeous idea, that the forces aren't furniture the universe happens to keep lying about, they're forced into being the moment you demand a symmetry hold, at every point separately, all across space. Beautiful. And then, just as I was reaching for my coat, you left me with something sharp under the skin.
Say it back to me, exactly as it pricked.
That the same beautiful logic wants everything to weigh nothing. The photon, the particle of light, the very thing that first symmetry forces into being, the rule insists it be massless, and the photon obliges without a word of complaint. No weight at all, and off it goes at light's own speed, forever. Lovely for the photon, but then you told me the identical reasoning, taken at its word, wants the matter particles massless too. The electron, weightless, which is plainly, obviously false, because the electron has mass, I'm built out of the things, and I am most certainly not weightless.
Not false. A puzzle. and a properly vicious one. Because the electron does have mass, you can weigh its effects. It's as solid a fact as physics owns. And some of the force carriers, unlike the easygoing photon, are downright heavy. Sluggish, hefty things, the ones behind the force that lets the sun burn at all. So we are caught in a vice. On one jaw, a symmetry too gorgeous to give up. It's where the forces come from. It's the deepest thread in the whole tale. On the other jaw, a plain fact. Things have weight. And the symmetry, left to itself, forbids it.
So one of two things has to give. Either the symmetry is a beautiful liar and we throw the whole gorgeous thing out.
Which we would sooner cut off a hand than do.
Or something else is going on that the bare symmetry never mentioned. Something that lets the electron be heavy without turning the symmetry into a liar, a loophole, a side door.
That's the knot, entire. And mark carefully what we are forbidden to do, because this is the part people skate straight past. We are not allowed to simply reach in and paint a mass onto the electron by hand, the way you'd scribble a number into a ledger. It sounds like the obvious fix. It is not allowed.
Why not? If the electron's heavy and I want my theory to say so, why can't I just write the weight in, put a mass in the book and be done?
Because the instant you try it, the symmetry shatters in your fingers. The whole structure that hands you the forces, the thing we spent last week marveling at, it depends on those particles being able to shift and mix in a certain seamless way, and a mass painted on by hand jams that mechanism solid. It's like gluing one gear in a watch to prove the watch keeps better time. You don't fix it, you stop it dead. Mass, sprinkled on by hand, wrecks the one thing we most want to keep.
So the theory's as delicate as that, one number jotted into the wrong margin, and the whole cathedral comes down around your ears.
As delicate as that, and the delicacy is a gift, not a curse. A theory that shatters the instant you try to cheat it is a theory that's telling you something true about how the world is actually put together. It simply won't let you lie to it. So the physicists stopped trying to lie and started asking the harder question instead. Where could the weight honestly come from, if not from inside and not from the pen?
So the mass can't be built in because the symmetry won't have it, and it can't be painted on because that smashes the symmetry too. It has to come from somewhere off to the side, somewhere the symmetry doesn't have to look at directly.
Now you're standing exactly where the physicists stood, staring at exactly the wall they were staring at. The electron is heavy. The symmetry says it mustn't be, and you may not cheat. So, where on earth does the weight come from, if it's forbidden from the inside and forbidden from the outside both?
I'll be honest, part of me wants to just shrug and say, well, maybe some particles simply are heavy, and that's the end of it. Why isn't "it's got weight, full stop" a perfectly good answer?
Because it simply is where physics goes to lie down and give up. Every single time the world looked as though it merely was some way and somebody stubborn refused to accept it, a deeper reason turned out to be hiding just underneath. Weight felt like the most brute, plain, bottom-of-the-barrel fact there could be. A thing has heft, end of discussion. And it turned out to be nothing of the kind. It's earned, or borrowed, or bottled. It simply is was never going to be the answer here. It hardly ever is.
I genuinely don't know, and I've turned it over twice now. Tell me you're about to.
I'm about to. And the answer is the field I opened with, the one filling every empty corner of the room. Here's the whole turn of it, and it's subtle, so let me lay it down slowly. Imagine every single point of empty space. Not the air, mind, the space itself, the bare stage the air stands on, is soaked in a field that is simply always on. It never rests, never drops to nothing, never switches off, not for an instant, not anywhere.
Now hold on, that's already a strange sort of field. Every other field you've shown me all season sits at nothing until something stirs it. The field of light is calm and dark until a charge waggles. But this one's never calm, never dark. It's just humming away at some level everywhere, doing nothing, going nowhere.
That's exactly the oddity, and you've put your thumb right on it. Every field you've met has a natural resting state of zero, flat, quiet, switched off until poked. This one's resting state isn't zero. Its most comfortable, laziest, lowest condition is to be switched on, everywhere, at one even value. Empty space, the emptiest, most nothing space you can imagine, scraped clean of every particle, still has this field humming through it. That's what makes it the odd one out. Nothing is not nothing. Nothing is full of this.
And nobody ever notices, I suppose, because it's the same everywhere. No edge to it, no gap in it, no dry patch to hold up against the rest and go, aha, there's the field, and here isn't.
That's exactly why it hid from us for the whole of history. A fish, they say, is the very last thing that would ever discover water, because the water is everywhere it goes, pressing evenly from every side, never varying, so it simply never shows up as anything at all. You'd only ever notice water if you stumbled on a dry patch. And in this field, there is no dry patch. Not one, nowhere in all of creation. So of course the thing stayed invisible. It never varies enough, from place to so much as cast a shadow you could point at.
And I take it this is not a field I can feel or see or trip over on the way to the kitchen.
You feel it every second of your life. You just don't feel it as a field. Here's the move, and it's the heart of the whole night. Stop thinking of a particle's mass as something the particle simply has, like a stone in its pocket it was born carrying about. Start thinking of mass as something the particle gets from the field continually by how strongly it talks to it.
And that never switches off business. That's not just a curiosity, is it? You keep coming back to it. I think it's doing real work in the argument.
It's doing all the work. Because a field that's on everywhere is a field that every particle is forever swimming in. There's no quiet corner to slip off to and be your true, weightless self. If the thing switched off in empty space, a particle could sit in the dark and weigh nothing, and we'd be right back staring at the puzzle. It's precisely because the field is never ever off that it can hand out mass everywhere, to everything, all the time.
Run that past me again, slowly, because it sounds like you've quietly shifted the furniture while I was looking the other way. Mass isn't a thing a particle owns outright, it's a thing a particle gets, earns, by carrying on some sort of conversation with a field that's lying everywhere?
Earns is close. Better still, mass is a relationship. It is not a property stamped on the electron at the factory and riveted on for life. It's how the electron and the space-filling field get along with each other. A particle that talks to the field a great deal comes out heavy. A particle that barely talks to it comes out light as a breath. And a particle that ignores the field completely comes out weighing exactly, precisely, nothing.
So the weight was never in the particle. It was in the handshake between the particle and the field. Which means, hang on, the electron all by itself, stripped of the field, is still the weightless thing the symmetry demanded. It only becomes heavy once it's dropped into the field and starts talking.
There it is. That's the escape from the vice, whole and entire. The symmetry gets its wish. The electron in itself weighs nothing, exactly as the rule insists. And yet, the electron you actually meet, the one swimming in the field that fills all of space, has real heft. The mass is genuine, but it's borrowed. It's on loan from the field. The particle never breaks the rule, it just never gets to be alone.
Because there's nowhere to be alone. The field's everywhere. You can't take the electron out to an empty room and weigh the real, massless thing because there is no empty room. Every room's already full of the stuff.
Not one empty room in all the universe. And that is why this works where painting on by hand failed. The mass isn't a fact riveted to the electron, spoiling its symmetry. It's a fact about the electron's endless conversation with a field it can never leave. The rule stays perfect underneath. The weight sits on top, borrowed, permanent, because the loan is never called in.
All right, but you keep saying some talk a lot and some talk a little. I want to see that. Give me the two extremes standing next to each other so I can watch the difference do its work.
Gladly, and let me draw it as a party, because the picture's daft, but it's honest. A room packed wall to wall with guests, and the guests are the field, standing everywhere, filling every inch. Now send a very famous face in through the door. The moment they step inside, people cluster round. Want a word, drift alongside, crowd in, and the famous guest can barely move. Every single step is a labour. They cross the room slow and lumbering, forever hemmed in. That clustering, that constant press of attention, that is what it is to be heavy.
So the famous guest is my electron then, draped in hangers-on at every step, working across the room.
The electron feels the field a little, a modest sort of celebrity, mildly mobbed, slowed but not stopped. Now think of the heavy force carriers, the sluggish ones, the W and the Z. They're the guest so wildly adored they can hardly manage a single stride without a crowd 3 deep pressing in from all sides. They talk to the field enormously, so they come out enormously heavy. And that's the rule you asked for, made visible. The more a particle couples, the bigger a fuss the room makes of it, the heavier it acts.
So weight is popularity in this ridiculous little world of yours. The keener the room is on you, the more it clusters and drags, the heavier you come out the other side.
Weight is popularity. That's the daft heart of it, and it's exactly right. The electron, a mild fuss, a little weight. The heavy carriers, a riot, a great deal of weight. Turn the coupling up, turn the weight up with it, in lockstep. Every particle's mass is written in one number. How hard the room leans in when it walks through.
So if I lined every particle up in a row, lightest to heaviest, I wouldn't really be lining them up by weight at all. I'd be lining them up by something else, by how chatty each one is with the field.
You'd be reading the guest list off in order of fame. The lightest particles are the ones the field barely troubles to nod at. The heaviest are the ones it can't bear to leave alone for a second. And there's no other ingredient hiding in it. Same field, same crowded room, and the entire sweep of masses in all of nature, from the barely there to the enormously heavy, is nothing but that one dial, turned up by different amounts for different particles.
And the photon? Where's the poor photon in this party of yours?
The photon breezes straight through, and nobody so much as glances up. It doesn't couple to the field at all, not one whisper of conversation. So it crosses the whole packed room without a single soul slowing it, clean through the middle, at full stride, and out the far door before the door's even finished opening. The photon ignores the field, and the field ignores the photon right back, and the two of them never so much as make eye contact.
The gatecrasher nobody recognizes. Sails through the party that the electron gets thoroughly stuck at. Doesn't spill a drink, doesn't slow a step, and is 3 streets away before anyone notices the door swung. And because nobody clustered, no weight. That's why light weighs nothing.
That's why light weighs nothing. And, mark this, it's why light must fly at the speed it does. A thing with no weight has nothing to hold it back from the one universal speed limit. It has no choice but to travel flat out forever. So the photon's masslessness and the photon's speed are the same fact told twice. Ignore the field, weigh nothing, fly at light speed. All one thing.
Now that flips something I'd had backwards my whole life. I always assumed light was fast because it's light, some special zippy sort of stuff, born quick. You're telling me it's fast because it's empty.
Fast because it's empty? Yes. The speed was never a talent the photon worked at. It's simply the default, the thing anything does when it carries no weight and nothing in the field ever reaches out to grab it. The photon isn't racing, it isn't trying. It's coasting at the only speed there is for a thing with nothing to hold it back. Weightlessness and that headlong speed aren't two facts about light. They're one fact, seen from two sides.
Same room, same crowd, standing everywhere, identical wherever you look. And one guest can barely shuffle across, while the other sails clean through untouched. And the only thing sorting their fates is how much notice the room takes of each. That's genuinely beautiful. One field for everyone, and it still hands out completely different destinies.
Same space, two fates, set by a single question. How much do you talk to the field? The electron a little, and it's a little heavy. The heavy carriers a great deal, and they're a great deal heavy. The photon not at all, and it stays weightless and quick forever. One field, filling everything. Every particle's weight written in how hard it leans on that one field.
But this even everywhere business snags me one more time, and it's the photon again. If the field's the same in every direction, offering the same thing to everyone, how does it know to grab the electron and wave the photon through? It's not aiming, surely.
It never aims. The field makes no choices at all. It's the particles that differ, not the field. The field just sits there, identical in every direction, holding out the very same handshake to everyone who wanders past. The electron takes the handshake and gets weighed down for its trouble. The photon strolls by with its hands in its pockets and takes nothing. Same offer, two answers. The field never singles a soul out. It only ever responds to whoever's willing to respond back to it.
All right, I'm thoroughly sold on the party, but there's a word you've leaned on 5 or 6 times now that's started to itch at me, and I want to pick at it before it drives me clean round the bend. Drag. You keep saying the field drags at the heavy particles. Now, drag, to my ear, means one thing, wading through mud. Treacle, something that grabs hold of you and slows you to a crawl, and finally hauls you to a dead stop. Is that what's happening? The field's a great sea of syrup, and heavy particles are the ones stuck slogging through it.
No, and I'm so glad you snagged on that word, because it is the single most misleading thing anyone ever says about this, and the picture in your head at this exact moment is wrong. Genuinely, importantly wrong. So let me stop the whole night here and pull it apart, because if you walk out that door believing the treacle, you'll have swallowed the one real error in the entire story, and it'll poison everything else.
Then pull it apart and take your time over it, because right now I've got a firm, vivid picture of a little electron labouring through cold porridge, and you're telling me to throw it out.
Throw it out. Here's the flaw, and it's fatal. Treacle slows things down. Set a marble rolling through syrup, and it drags, and slows, and stops. The syrup steals its motion, bleeds off its speed, until the marble sits there dead still in the goo. That's friction. That's a force fighting the marble's movement, actively taking its speed away. And the field does nothing whatsoever of the kind. Nothing. Take an electron out in the middle of empty space, coasting along with nothing pushing it, and it coasts along at that speed forever.
Forever? The field never slows it, never bleeds off a scrap of its speed.
Never a scrap. Leave it alone, and it drifts at that same pace until the last star burns out. The field does not steal its motion. There's no syrup, there's no braking. A free electron, once moving, keeps moving, serene and untroubled, world without end.
But then, hang on, that's the exact opposite of drag. If nothing's slowing it down at all, if it just coasts on untroubled forever, Then what in the world is the field even doing to it? Where's the heaviness gone? What did the weight ever mean if the thing sails along unbothered?
Here's the difference, and it's the whole of it, so hold still. The field doesn't resist the electron's motion. It resists any change to the electron's motion. Read that twice. It is not hard to keep the electron moving. That's free, that's forever. It's hard to get it moving in the first place. Hard to speed it up. Hard to slow it down. Hard to swerve it off its line. That resistance, the electron's sheer stubbornness against being pushed around, against having its motion altered at all, that is its mass. That is what heaviness actually is.
So mass was always this then, even before you said a word about any field. When I shove a heavy crate and it barely budges, that stubbornness in it is the very same stubbornness.
The very same, all the way down. The heft of a boulder and the heft of one lone electron are the same kind of thing at bottom. A flat refusal to have one's motion changed without a proper fight. What the field does is hand the fundamental particles that refusal in the first place, right down at the smallest scale there is. Stack enough of them together, bind them up into a crate, and all those little refusals add up into the ordinary, everyday heaviness you already know in your arms. Mass was never a mystery about what it is, only ever about where it comes from.
Oh, that's a completely different animal. So it's not that the field's fighting the electron the whole way across the room, stealing its speed. It's that the field makes the electron hard to get started, and hard to stop once it's started, and hard to turn. But once it's cruising along, the field leaves it entirely in peace.
That's it precisely, and you've said it cleaner than most textbooks manage. Forget syrup, think of sheer heft. A shopping trolley loaded to the brim with bricks isn't being braked by anything. Grease the wheels all you please, oil them till they gleam. But heavens, it's a job to get the thing rolling from a standstill, and a worse job to stop it once it's underway, and a downright nightmare to steer it round a corner. That reluctance, that stubbornness against being shoved about, is exactly what we mean by mass. The field lends the electron its heft. It does not lend it friction. Coasting is free, only changing your mind costs.
Only changing your mind costs? I like that, but let me test it, because I'm always wary of a phrase that goes down too smooth. If I could reach in and shove an electron sideways, a harder shove for a heavier one, that's the only moment the field shows its hand?
That is the only moment it ever shows its hand. Push a heavy particle and a light one with the exact same shove, and the heavy one budges less. Grudging, reluctant, dug in. That grudgingness is the whole of what the field gave it, start to finish. Not a drag while it travels. You would never once catch the field working on something already gliding along steadily. Only in the shove, only in the change of course. The bill falls due the instant you try to alter the motion, and never, not for a heartbeat, while the thing simply drifts.
So every single time I've heard someone say particles wade through the Higgs field like walking through honey, that was quietly walking me off a cliff. It's not honey. There's no slog. It isn't a drag on the motion at all, not in any everyday sense of the word. It's weight, pure heft, the resistance to being pushed, and that's a far stranger thing than treacle when I actually sit still with it, because treacle at least I understand in my bones.
Far stranger, and far cleaner. And you should trust the strangeness. It's the sign you've got the real thing and not the cartoon. The cartoon is comfortable and wrong. The truth is odd and right. The field doesn't slow you, it weighs you. It doesn't take your speed, it gives you inertia. Keep that straight, and the rest of the night stays honest. Muddle it, and you'll believe the universe is full of glue, and it simply isn't.
And here's a thing that just struck me. If it were glue, if it genuinely dragged, then I'd feel a wind, wouldn't I? Moving through space, I'd feel the treacle streaming past my face. And I don't. Nobody ever has.
Nobody ever has, and that silence is the tell. If the field braked moving things, then motion through it would carry a cost. A headwind, a sense of forever swimming upstream, and you could work out which way you were sailing through the universe just from the drag on your cheek. There is no such wind. You glide through the field feeling precisely nothing, because slowing things is simply not its trade. It only ever presents its bill when something tries to change its motion, and coasting along, minding your own business, changes nothing at all.
Right, that I'll carry out with both hands. Not glue, heft. But hold on, let me catch what just happened underneath all this, because I think you slipped something enormous past me while I was busy with the trolley.
Go on, catch it.
We handed the electron a weight. Real heft, real inertia, the genuine stubborn article. And we did it without ever once painting a number on the electron by hand. The very thing you told me a while ago I wasn't allowed to do.
There. That's the prize, and you reached out and took it yourself. The mass came from the field, not from the electron. The electron, in itself, is still the weightless thing the symmetry demanded. Pure, unspoilt, obeying the rule to the letter. The heaviness is entirely on loan, borrowed continuously from the field it's forever swimming in. And so
the symmetry never gets broken. That's what you're steering me toward, isn't it? The rule underneath still holds. Everything's massless if you could only strip the field away. But you can't strip the field away, it's everywhere, always on. And so what you actually see is a whole world full of heavy things.
that's the quiet triumph of the entire idea, and it's the reason anyone ever believed a field this mad could be real. Let me say it dead plainly, because it's the elegant heart of the thing. The deep symmetry from last week, the one that insists everything weigh nothing, that symmetry is still there, perfectly intact, not destroyed, not violated, not a liar after all. It is simply hidden, draped over, buried beneath a field that fills the whole of space so evenly, so silently that you never once notice it's there, and the particles swimming in that field pick up their heft as they go.
So the symmetry didn't lose the fight, it went undercover. The law still holds underneath, strip the field off, and everything's weightless again, obedient. But you can't strip the field off, it's woven through every empty inch of the universe. And so the world you actually live in is stuffed full of heavy things. The beauty survives, it's just wearing a coat it never takes off.
A coat that covers all of space and never once comes off. Not anywhere, not ever. That's the whole miracle of it. Mass appears, real and heavy and measurable, and the gorgeous structure from last week doesn't have to die to allow it. The symmetry is hidden by the very field that fills everything. That's not a footnote. That's the reason the field earns its place in the theory at all. It's the one idea anyone ever found that lets particles be heavy while keeping the beauty alive and breathing underneath.
But I need to actually feel the gap between hidden and broken, because from where I'm standing they sound like the same sad funeral for the symmetry either way.
They're worlds apart, and that gap is everything. A broken symmetry is gone, smashed, no longer true, a law you're free to tear up. A hidden symmetry is still perfectly true, still the deep law of the place. It's only that the world happens to be sitting in one particular state that doesn't show it off. Picture a round dinner table, every napkin set dead center between two plates, flawlessly even, no left or right to it, until the first guest reaches out and takes the napkin on their left. Now everyone must go left, all down the table. The evenness has vanished from the scene the instant a choice got made. But nobody rebuilt the table. The symmetry is still there in the wood, as true as ever. The field is that first choice, made everywhere in space at once. and the deep lore underneath is never so much as scratched.
Which is a lovely, lovely story, but it is, so far, purely a story. You've told me a field fills all of space and I can't see it, can't feel it, can't trip over it, can't scoop a jar of it up off the floor. So how does anybody actually know the wretched thing is there? Or is this an exquisitely elegant fairy tale that just so happens to make the sums come out right?
That is precisely the right question. The skeptic's question, and thank goodness for it, because it kept everyone honest for years. A field you can't see, that's always on, that never varies from place to place. How could you ever hope to catch it in the act? And the answer is beautiful, because it's the very same trick you'd use to prove any field at all is real. If a field is genuinely there, you should be able to make it ripple.
Ripple, as in poke it hard and watch it wobble?
Poke it hard and watch a piece of the wobble break clean off. Every field we've ever met behaves this way. It's the whole lesson of the quantum seasons, the thing we spent months on. A field, disturbed hard enough, doesn't merely shiver in place. A lump of the disturbance tears loose and travels, and that travelling lump is a particle. That's what a particle is at bottom, a ripple in a field, come loose and moving.
Right, that's the drum you banged all through the quantum episodes. Shake the electron's field the right way and out pops an electron. Shake the field of light and out pops a photon. The particle is the field, ringing.
The particle is the field, ringing. Exactly. So now put it together. If this new mass-giving field is genuinely there, soaked through all of space, then shake it hard enough and a lump of it should tear loose too. A ripple in the field standing up as a brand new particle. Its own particle, its boson. And if you can knock that particle out and catch it, you've proved the field was there all along. Because you can't ring a bell that isn't hanging.
And I'd wager a stiff field rings a heavy bell. If it's this reluctant to ripple at all, then the ripple you finally shake loose must itself be a hefty great thing.
A very hefty thing. Heavier than almost anything else we've ever laid hands on. Which is exactly why it took so monstrously long to find. The stiffer the field, the harder the wallop you need to disturb it, and the heavier the ripple that finally jumps clear. This boson wanted an energy so enormous to shake it loose that the machine built to reach it had to be the size of a landscape. It wasn't hiding because it was small and slippery. It was hiding because it was heavy, and heavy costs energy, and that much energy is desperately, desperately hard to cram into a single tiny spot.
So that's the whole test. Don't try to see the field, try to make it flinch. Kick it hard enough that a chip of it jumps loose. And if a chip jumps loose and lands in front of you, then the field you couldn't see was real the entire time.
That's the entire test. And kick it hard enough is no small ask, because this field is stiff, proud, reluctant, hard to disturb. It takes a colossal wallop to make it ripple even the tiniest bit. So you build a giant machine. Picture an enormous ring, miles and miles around, where you take ordinary particles and whip them up and up until they're a hair short of light speed. And then you smash them together, head-on, at an energy that beggars every description. All of it crammed into one unthinkably tiny spot, over and over and over again, for years, just to shake that stubborn field hard enough to make it so much as twitch.
And did it twitch?
It twitched. After a long, patient, dogged hunt, smash after smash after smash, more collisions than you could count in a lifetime, the field flinched, just once, just enough, and a ripple broke loose. And there it was, a brand new particle, exactly the lump of field the idea had promised, decades before, jumping out of the wreckage at last and landing in the detectors. The Higgs boson, the living proof that the field was never a fairy tale after all.
So the field stopped being a story the very day they shook a chip off the top of it. Honestly, that's thrilling when it lands. You reason your way, on paper, to an invisible ocean filling every empty inch of the whole universe. Everyone doubts you for a lifetime. And then you build a machine the size of a small country, and you belt that invisible ocean so hard that a single droplet leaps up out of it and splashes onto your instruments. And there's your proof. Found. There it is. The thing was real all along.
Found at last, exactly so. And on that day the whole world cheered. As well it might, it was a magnificent piece of work. But this is where I have to be honest with you, in just the way the cheering headlines mostly weren't. Because now we come all the way back round to your hand, the one you held out at the very start of the night, the one that has weight, the one you wanted explained. And the honest truth of your hand is the part that almost nobody bothers to tell you.
This is the twist you dangled off the edge of the very first minute, isn't it? That the famous field gives me almost none of my weight. Go on then, land it properly. I've been holding my breath over it for the whole hour.
Then here it is, plainly, and I will not dress it up or soften a corner of it. That field, the one they found, the one the world celebrated, it hands out mass, yes, but only to the elementary pieces. The truly fundamental bits, the ones with nothing at all inside them. The electron gets its weight from the field. The quarks get theirs. The heavy carriers, the W and the Z, get theirs. All true, and all a genuine triumph. But now, look hard at what you are actually built out of.
I'm built out of atoms, and the atoms are mostly, the heavy knot in the middle? The nucleus. Protons and neutrons, jammed together.
Protons and neutrons jammed together, and that is where very nearly all of your weight lives, in those. Now here's the fact that ought to stop you dead in the street. A proton is not elementary. It is not a fundamental speck. It's built out of smaller things, little quarks, 3 of them, jostling and racing about inside it. And those quarks, yes, do get their own mass from the field, just as we said. But add up the weights of the 3 little quarks inside a proton, and you get barely 1/100th of what the whole proton actually weighs. Barely 1/100th.
Wait, that can't be right. The quarks are the ingredients. They're what the proton is made of. And the ingredients, all added up, come to a single 100th of the finished thing. Then where in the world is the other 99 parts? Where's nearly the whole weight of the proton, if it isn't in the stuff the proton is made from?
It's in the energy. The 3 quarks inside a proton are bound together by the strong force, the fiercest grip in all of nature, whipped round and round each other at a savage pace, held in a cage of pure ferocity, an absolute storm of energy roaring away in there just to keep those 3 specks locked in. And that energy has weight. Energy and mass are the very same thing, wearing 2 different coats. That is Einstein's oldest and most famous idea, the one everyone can half quote and almost nobody quite believes in their bones. Bottle up energy and it weighs. And a proton is a bottle absolutely thundering with the trapped energy of the strong force.
The neutron too, then, the other thing crammed into the nucleus alongside the protons. Same story in there?
The very same story, wall to wall. A neutron is 3 little quarks as well, held in the same ferocious grip, thundering with the same trapped energy. And its weight comes overwhelmingly from that grip, and barely at all from the field. So every proton and every neutron packed into you, which is to say, very nearly the entire mass of you, is a small, roaring cage of strong force energy. You are, near enough, a walking thunderstorm that has agreed to hold still.
So the proton is heavy, not because of what's inside it, but because of how violently the inside is being held together. The weight is in the grip, it's in the storm, it's in the sheer bound-up energy of caging 3 feather-light quarks and never once letting them go.
Nearly the whole of it, yes. The quarks bring in a mere whisper of mass from the field, 100th part, a rounding error. The strong force, raging and roaring to bind them, brings all the rest. The overwhelming, crushing rest, as pure bottled energy, cashing Einstein's equivalence, every last scrap of it pressing down on your bathroom scale as honest weight.
And so, when I hold my hand out and feel it pull downward,
Almost none of that pull is the famous field. Almost the entire pull is the energy of the strong force, locked up tight inside the protons and neutrons that make you. Your weight, the number on your scale, the heft in your held-out hand, it is very nearly all bottled-up motion. Frozen storm, caged thunder, sitting still, weighing exactly as much as all that trapped fury comes to.
so the thing I stood on the scale to measure, the solid, obvious, undeniable morning after Christmas heaviness of me, is mostly not stuff at all. It's energy. It's the strong force holding my quarks in a headlock, and the price of that headlock paid out as weight. And the great famous field the whole species celebrated, it's in there somewhere, it's real, but on the scale of my body, it's a rounding error. Nearly the whole of me is bound up energy, wearing the costume of solid substance and fooling me completely.
Nearly the whole of you. And I want that to land properly and stay landed, because it is the truest and the least told thing in the entire subject. The field explains why the electron has any mass at all, why the quarks have any, why the heavy carriers are so heavy. That is real and deep, and it took a machine the size of a country to prove. But it does not explain your weight, or the weight of a brick, or a book, or anything you can pick up and heft in your hand. That is the strong force, and Einstein, and energy given heft. Do not let the famous field take the credit for that. It never earned that one, and it never claimed it. The credit was pinned on it by people who weren't listening carefully.
And even the parts of me that do get their weight honestly from the field, my electrons, those are the featherweights of the atom to begin with.
Whispers, the lot of them. An electron is thousands of times lighter than the protons it circles, so even in the one place the famous field is doing its genuine, honest day's work inside you, handing your electrons their mass, it's dealing out featherweights, a vanishing sliver of your total heft. The field's real customers, in your body, turn out to be the very lightest things you own. And the heavy machinery of your weight, the part the scale actually reads, runs on something else entirely.
Let me push it one last way though, because I want to be dead sure I couldn't wriggle out of this. Suppose you could reach in and switch the famous field clean off. My protons, do they suddenly go light?
Barely a flicker on them. Switch the field off, and the quarks inside lose their little whisper of mass, that 100th part, and your electrons lose theirs into the bargain. But the strong force storm keeps right on roaring, untouched, because that energy never came from the field in the first place, and so the proton stays very nearly as heavy as it ever was. Turn off the single most celebrated field in all of physics, and your bathroom scale would scarcely notice you'd done it. That right there is the whole honest caveat packed into one clean test.
And that's why you flinched a little earlier every time I said, the field that makes things heavy. Because it doesn't. Not the everyday kind of heavy. It makes the tiny, fundamental, invisible bits heavy. The ordinary heaviness of the ordinary world. A stone, a body, a hand held out in the air. That's somebody else's doing entirely. And mostly it's the strong forces.
That is exactly why I flinched. And it's the very reason there's a nickname for this thing that makes everyone who actually works on it wince clean out of their skin. You'll have heard it. It's on every book cover ever printed on the subject. They call it the God particle.
Oh, I've heard it all right. The God particle. It's on the documentaries, the magazine covers, the lot. I'd rather assumed the physicists were quietly chuffed with the grandeur of a name like that.
Not one of them can stand it. Not a single one. Ask anyone who spent a life on the thing and watch their whole face fold up in pain. Because the name promises precisely the lie we've just spent the last hour carefully dismantling. That this is the origin of all mass, the thing that gives the universe its very substance, the deep secret of why there's anything heavy in creation at all. And it is none of that. None of it. It's a field, and it's ripple. That's the honest, complete description.
So where does a name that grand even come from, if the very people who'd know all wince at it?
A book needed a title once, and grand titles sell copies, and the grandeur stuck fast like tar, long after everyone who actually understood the thing had begged that it wouldn't. And with the name came its whole overblown retinue trailing behind. That this is why there's something rather than nothing, that it lends the cosmos its substance, that it's the very fingerprint of creation. Every bit of it too big by miles. Its real name is a plain one, the Higgs boson, the ripple of the Higgs field that fills all of space. It gives certain small particles their mass. That is the true miracle, and it is quite miracle enough, thank you, without dragging the divine in to gild it.
A real, staggeringly hard-won piece of the puzzle, worth the machine, worth the years, worth the cheer on the day it jumped out, that explains the masses of the fundamental bits. And not 1 inch more than that.
Not 1 inch more, and not 1 inch less. It is a genuine, beautiful triumph, correctly scoped. It is not the source of all mass. It is not what gives the world its solidity. It is certainly absolutely nothing to make a god of. Keep the wonder. The wonder is entirely earned, an invisible ocean filling all of space, caught at last by shaking a drop loose. But keep the wonder honest. A grand name is a check the physics flatly refuses to sign.
So, keep the ore, lose the incense.
Keep the ore, lose the incense. Put that on the poster instead. The ore is real, and it's plenty. An invisible field filling the whole of space, hidden clean through the entire history of the world, dreamt up first on paper and then dragged bodily into the daylight by shaking one heavy drop loose from it. That is about as wondrous as science ever gets. It simply isn't holy, and it isn't the wellspring of you. Wonder and honesty were never enemies, and the honest version here turns out to be the more wonderful one anyway. It nearly always does.
So let me try to gather the whole night up into one armful before you send me back out into the cold. Some things are heavy. My hand is heavy, and it turns out there are 2 completely separate reasons a thing can have weight, and I walked in here this evening assuming there could only ever be the one.
Say them both. Plainly, in your own words. You've done the work tonight. You've earned the plain telling of it.
The first reason is the field, the unseen thing filling every scrap of space, always on, never resting, and the elementary particles, the electron, the quarks, the heavy carriers, get their mass from how hard they talk to it. Couple a lot, come out heavy. Couple a little, come out light. Ignore it completely, like the photon, and stay weightless and quick forever. And it works this small miracle without ever breaking the beautiful symmetry underneath. It just hides that symmetry beneath a coat that covers all of space and never comes off. That's the first reason anything weighs anything.
And the second, the big one, the heavy one, the one that's actually holding your hand up against the pull of the earth right now.
The second reason is energy. Bound-up energy handed its weight by Einstein. Nearly the whole of my heaviness has nothing to do with the field at all. It's the storm of the strong force raging inside every proton and neutron in me, holding my quarks in their cage. And that raging trapped energy weighs. So my weight is mostly frozen motion. The single most solid, obvious, undeniable fact about my whole body, that it's heavy, that it pulls down, that a scale can read it off in the morning, turns out to be a little bit of conversation with an invisible field, and mostly, overwhelmingly, bottled thunder.
That's the whole of it, held in one armful and held honestly. And look where the seasons carried us now. We've met the matter particles, the ones you're built from. We've met the forces and where they come from, the symmetry that forces them into being, last week's great turn. And tonight we've met the last field of the whole set, the odd one out, the one whose only task in all the world is to hand the elementary bits their weight. Nearly every card is on the table.
Nearly, but not yet laid out flat, all at once, face up, where I can finally see the entire hand together in one glance.
Not yet. And so that is exactly where we go next. Next time, we finally put every card down at once. The matter, the forces, the field of mass, the whole cast, laid out flat in a single picture, and we see what the whole thing looks like assembled. It has a name, and it's a strikingly modest name for what it actually is. The Standard Model, the most precisely tested theory in the entire history of science, checked against reality to a savage depth of decimal places, and never once, not one single time, caught telling a lie. And everything, it triumphantly explains.
Everything, though not quite everything, I'd guess, or you'd hardly have the last few weeks of the season still up your sleeve.
You've been paying close attention. It explains very nearly everything you will ever meet, to a precision that ought to frighten you. But there are one or two hairline cracks in it, right out at the edges, that it simply cannot paper over. And your own weight tonight was a first quiet hint of how much richer the world is than any single field. We'll get to the cracks, in their turn. But first, next week, we stand back and admire the thing whole.
The whole hand, laid flat, all at once, next week.
The whole hand, laid flat, all at once. Next time, the whole thing, assembled.
Good, because I came in here tonight wanting one small, simple thing explained. Why my hand has weight. And I'm leaving with the ground gone soft and strange beneath me. A sliver of that weight, 100th, no more, is a quiet conversation with a field I will never once see. And nearly the whole of the rest is a thunderstorm of pure energy, frozen solid, that I have been carrying around inside me my whole life and calling it simply me. Heaviness, the most ordinary thing in all the world. And it was never, ever as simple as it felt sitting there in my open palm. I'll hold my hand out again on the walk home, and this time at least I'll half know what's really pulling it down. See you next week for the whole hand laid flat.